Boom! It's your boy. No, that's actually cringe. Well, hi. My name is Evangelos Stamatis, and I'm here today to showcase to you guys one of my latest creation, which is a bus stop. Yeah, you heard it right. It's actually that simple. I'm a fucking genius myself, and I've solved one of the world's biggest problem: waiting on a bus stop. Thank you. I'm out. No, I'm just kidding. Let's take it more seriously. Well, here in Athens, Greece, where I currently live, there are a lot of buses that can take you places and a lot of bus stops. And one of the biggest problem is me waiting on that bus stop. When it rains, when it's windy, when it's noisy, I don't like it. Probably you wouldn't like it. So I came up with a simple solution. Take the bus sign, compress it, and get it in my house. Okay, so let's go ahead and take a look on how that might look like. When I actually said compress the bus stop, I actually meant that I have to rebuild it. Build it in a smaller size actually, and it turned out to look pretty amazing actually. Here it is. This is the whole build. Inside of here, there is actually a microcontroller that makes requests to a public API, fetches data, formats data, and then prints it into this little screen. This is a 16:2 LCD display. To better understand how a device like this might work, it's better if we use a simple schematic in a whiteboard that can guide you through the whole process. With the help of my extraordinary sketching skills, we're gonna get started and analyze the modules that we used for a device like this. To begin with, we can start with the main module of the project. We can say the brain of the whole device, which is an ESP32 microcontroller. This module is responsible for three things: making API requests, connecting to the Wi-Fi, and of course formatting the data. The data formatted by the ESP32 are later sent to an I2C communications module that is mainly responsible to translate the data into something a 16:2 LCD display can understand and print. If you don't have the I2C module, the 16:2 monitor will probably print gibberish, something that the user cannot understand. Version 1 of the whole project actually works. It is doing what it is supposed to do, but there are some limitations. There isn't a user interface, so the user can interact with an application and set it up to his likings. Values like the Wi-Fi password, the Wi-Fi SSID, and the bus stop ID number are all hard-coded inside the base code. So someone has to know how to code and use the code and upload it to the ESP32 for the whole project to work. That makes it hard for users because they have to know how to set up an ESP32 and use the base code to actually modify the bus stop for their likings, for their bus stop of interest. So they can view the data of the bus stop they want and connect to the Wi-Fi they want, not my Wi-Fi. So you might be wondering, but Evangelos, how am I supposed to actually set the whole code if I don't know how to use an ESP32 microcontroller or even use a computer software to actually code stuff and upload it to the microcontroller? I'm gonna tell you, my friend. My whole genius, this big head, came up with the second version of the project that actually helps the users set up the whole application. In order to better understand the whole process of how to set such a project, it's better for me to show you in person. Like, I'm not gonna come to your house, but in this video, you're gonna see how to set up the whole project and where to access the user interface and set your Wi-Fi credentials and the bus stop IDs. and we can maybe talk about other problems that the version 2 generated to the whole project. When you connect the device for the first time, the first thing you're going to see in the monitor is this exact message that is telling you that the device has started in access point mode, and it's showcasing an IP address that you can follow in order to view the UI and actually configure the whole device. Moving over to your PC, you can navigate to your Wi-Fi settings, where you can find the Wi-Fi ESP32 setup. This is the Wi-Fi provided by the ESP32 when it is on access point mode. By simply connecting to the Wi-Fi and typing in the browser the IP that the ESP is showing on the monitor right now, you will navigate to the UI for the mini bus stop. You can actually type your Wi-Fi SSID, your password, and 4 bus stops of interest. After filling the Wi-Fi SSID and password, and maybe you input 2 out of 4, let's say, bus stops of interest, you can click Save and Connect. This will update the configuration on your ESP, and you will be provided this message that says that the configuration is saved and the ESP32 will restart. Back to our device now, we can see we have successfully connected to the Wi-Fi and we're fetching and viewing data for each of our bus stops. In the data we see, we can actually identify the number of the bus, the arriving time, and some basic route information. Back to our drawing board, I want to talk a little bit more about the second version of the project. Even though the second version of the project actually solved problems like the configuration of the whole system or being limited to only having one bus stop viewed at a time, it actually generated a lot of timing issues. What I mean by that is that when you have configured more than one, let's say 3 different bus stops, and you want to view data for each bus stop, you have to go through cycling each bus stop and, first of all, reading the ID, fetching the data, formatting the data, and finally printing them. And then you have to go back and do the same process for the next bus stop. I've probably bored you enough with the schematics, the whiteboards, and me explaining stuff you probably don't even care about. Just bear with me one more minute. I really need to tell you about the algorithmic state machine. It's actually a very interesting part of the project, and I can't believe how well it worked when I actually implemented that. So an algorithmic state machine is actually used in devices like this, in embedded systems, because all they do is a series of procedures. You see, the device is actually making API requests, then after getting the data from that request is formatting the data, and then sends them to print. That's the 3 main processes. But when you want to have more bus stops from 1 to 4, you have added stuff like you need to actually serve the UI first. After entering the data of the UI, you need to iterate through the 4 bus stops and get the ID, pass it to the URLs, fetch the data, format the data, send them to the monitor, and then roll back and do that all again. So this is actually what an algorithmic state machine does. It's 5 or 6 or 3 or I don't know how many steps you have following that order, and you can't proceed to the next step if you don't complete the current step you are in. It's that simple, but it's solving way too many problems, because a machine like that has timing issues and printing issues on the monitor. If you don't actually format the data correctly and you have some time that you can only print data and you are not doing anything else, then you probably see gibberish, you probably see symbols in the screen, and you can't have understandable data. So yeah, thanks again. We can move on to the next part of the video, which is going to be a late montage of me building the device and actually seeing it work for the first time. So yeah, peace out. Thank you. And there you have it, our first completed project. Hope you guys enjoyed the video, maybe learned something useful from it. Leave any comments you have in the section down below, any suggestions, improvements, anything, because of course this project is not perfect. There are still some problems when there are a lot of buses coming to a certain bus stop and the data is too much. Maybe with a quick reset the whole problem resolves, but we can maybe fix that as well. Thanks again, and till next time, keep enjoying life.